Okay, so we've got a formula to balance. We've got CS plus N2 yields CS3N. And so to show what these little things are, we're going to use Lego. So we've got CS, and then we've got an N2, and then we've got CS3N. So you can see there's one CS here, there's two N atoms here, there's three CS atoms plus N. We cannot take these apart. We cannot just add things to them or take them apart or any of that. We have to keep them. We can have as many of these as we want, or as many of these as we want, or as many of these as we want. And we need to make sure that we start, which is these reactants over here, we start with the same number that we end up with. And so the way that we do that is we add more. So if we want to add more cesium, or if we want to add more CS over here, then we can. If we want to add more of any three of these, then we can. But we need to start out. So if we look, we started out with 1 CS, and we ended up with 3, and that's not possible. So law of conservation of mass, we can't destroy matter or mass. So we're starting out with 1, and we're ending up with 3. We need to start out with 3 because we can't destroy them, but we can add more of these. The same thing here, we have more N's on this side than this side. So if I were given this equation, then the way that I would look at this is, if I need to change this, well, first off, let's do this. Let's go ahead and try to write it out. CS and N. On the left side, we have 1 CS, and then we have 2 N's. We see that here, 1 CS and 2 N's. On the right side, we have 3 CS's and 1 N. So that's what the visuals down here, and the formula, what we'd actually do, kind of keeping score of what's going on up top. So we could just start adding CS's, which would be fine. I tend to try to do the more complicated molecule first, but either one is fine. So we're going to add a 2 right here, which is just like adding another one of these. And again, you can have as many of them as you want. If you wanted to put 30 on there, you could. That wouldn't help you balancing very much, but I would just go up. Since that was a 1, I just go up to the next coefficient, which is 2. So now let's reassess. So we've got 6, 1, 2, 3, 4, 5, 6, 6 CS's, and I can do that by 2 times 3. The coefficient times the subscript, that's 6. And there are 2 nitrogens, and I can see that right here, 2 times the 1 that's right there. Okay, well now we're good on the nitrogens, but now we have a CS problem. We have too many on the right side and not enough on the left, but it's easy to fix because CS is all by itself. So we're going to put a 6 right here. And that's going to look like bringing these in, and they're not connected. They're all individual, just like the CS3N was. And now we start off with 6, we end up with 6. We start off with 2, we end up with 2. This formula is balanced, and hopefully the Legos helped you visualize that.